If you've ever hit the slopes, you'll know what a mogul field is. That's when the piste gets littered in snowy bumps. Moguls are rarely ever made on purpose. They're a natural consequence of people using the slopes. The way skiers regulate their speed is by turning, but if there's loose snow on the piste, they'll carve a path through it, and turning especially causes mounds to form as that snow gets pushed out of the way. As more and more people use the piste, taking similar paths, they carve deeper and deeper grooves and make larger and larger bumps. You can think of the moguls as a wave in the snow. They are oscillations in its height. And when we talk about processes that generate waves which grow exponentially in amplitude, that's known as an instability. And there's a different instability that causes an analogous mogul field in space.
The supersonic solar wind gets slowed and deflected around Earth's magnetosphere by a shock wave, the bow shock. But this shockwave also energizes and reflects a small proportion of those particles back towards the sun, forming the foreshock region, which is rife with a zoo of instabilities and waves. One class of these waves were the very first thing I ever did research into, the so-called 30-second waves, which look a bit like this. Except using data from the cluster mission, I showed that these waves are far more like a mogul field. They're bumps, not perfect ridges. This was something that we hadn't predicted, and actually only very recently have computers been good enough to simulate the same things that we saw in the data. But whilst we know these waves do form a mogul field in space, quite what makes the moguls the size they are is still something of a mystery.